Hi everyone, this is Physics Part 2. This is shows a summary for Section 2. Work net equal the change in kinetic energy. This is work net kinetic energy theorem. And this is an explanation for sample problem, page 161. This is the practice, page 162. It was on a homework. Question 1. D equals 7.8. Question 2. D equal 2.1 meter. And the question 3, there is an incline, there is an angle 20, but this angle between the vector and y-axis, the angle between the vector and x-axis 70, so you can use sine 20 or cosine 70 to find fgx, the fg component in x-axis. Question 4, the F net equal 300. Potential energy. Now we will talk about another kind of energy, the potential energy. Potential energy, it's called also the energy of position. Because of the object's position, or when the object is with height, according to a reference point of Earth surface, when you release it, will accelerate downward and finally will get some kinetic energy. From where this kinetic energy came from what kind of energy called potential energy. Or actually in this position, it's called, in this situation, it's called the gravitational potential energy. Also, if you use a spring and stretch or compress a string, this kind of energy will convert to the kinetic energy. From where this energy comes from the elastic potential energy. So potential energy, we can part it in two parts. Potential energy two parts: gravitational potential energy, gravitational, this is the symbol of gravitational potential energy, and elastic potential energy, elastic. There is another kind of potential energy actually, like the electric potential energy, but now we will study only the gravitational potential energy and the elastic potential energy. Potential energy at all defined as the energy associated with an object because of the position. Position, we mean actually the gravitational potential energy, or the shape, if there is a spring or rubber, or a condition of the object. Gravitational potential energy, you can find it by using M times G times H. So there is three factors affect the gravitational potential energy: the object mass, and the acceleration due to Earth gravity, and the height of the object. As much as height increase, as much as the gravitational potential energy increase. And the unit of the gravitational potential energy, joule also. So the energy, all the kinds of energy and work. And the elastic potential energy elastic, equal half k x squared. K, it's the spring constant or the force constant. It's describe how much is flexible or stiff this spring. X, the displacement, how much the object, the spring, compress or stretch. Let us back to the gravitational potential energy. Again, M, it's mass, the object mass. A, it's the G, it's the acceleration due Earth gravity, G. The acceleration due Earth gravity, the free fall acceleration, equal 9.8 meter per second squared, and H, the object height. But gravitational potential energy, again, the potential energy stored in the gravitational field of interacting body. There is a gravitational field. This gravitational field is stored a kind of energy called the gravitational potential energy. Yeah, there is a concept or something called the zero level. Zero level is the vertical coordinate at which gravitational potential energy is defined to be zero. As example, if there is two different height or two tables or two buildings, if there is an object there, if you consider this place or the second building is the zero level, that means the kind of potential energy stored there, it's just H1. If you consider the zero level, it's the air surface, that means the amount of gravitational potential energy, it's equal to H2. So that means if the object at position A, at building the first building at position A there, still have some of gravitational potential energy. So you can take the zero level as the second building or the air surface, and usually in most questions the zero level, the air surface. Now, elastic potential energy. X, we said X, it's the distance compress or stretch, and we are caring only about how much it's compress or stretch to find the amount of elastic potential energy. K, it's called the spring constant, and the unit it's in Newton per meter. By another word, you can say it's the amount of force that need to compress or stretch the spring or the elastic object 1 meter. This is K. K describe how much the object flexible or stiff stiff. If K small, this is flexible spring. If K large, this is stiff spring. And the definition of elastic potential energy, the energy available for use when deformed elastic object return to the original configuration. Spring constant, a parameter that is a measure of spring resistance to being compressed or stretched. Also, there is a relaxed length. Relaxed length for the spring when there is no weight or no force acting on it. This is called, as example, without a force, a relaxed string, relaxed length. This is relaxed length, and this is how much the spring stretch. Now we will use the formulas of potential energy, the gravitational potential energy, mgh, and the elastic potential energy, half kx squared, to find the amount of energy or any unknown value. Look at the sample problem D, page 165. Problem D, page 165. In this question, there's two kinds of potential energy. There is elastic potential energy and there is a gravitational potential energy. The 70 kilogram person, the mass equals 70 kilogram, m equals 70 kilogram. The constant of the elastic object equal 71.8 Newton per meter, and of course G equal 9.8 1 meter per second square. There's two kind of potential energy. Potential energy total equal potential energy gravitational plus potential energy elastic. The most important things in this equation to find X and H. X, we care only about how much the flexible or the elastic object stretch or compress. It's written unstretched length equal 15 and stretched length equal 44. So X equal 44 minus 15. Relaxed length minus the stretched length equal 29 meter. And this is X. and h. At first the height it's 50, and when the flexible or the object stretch 44 downward, of course, 44. So h equal 6 meter. Now just substitute these values, use the formula mgh plus half kx squared equal, the mass equals 70 times 9.8 g1 times h equals 6 plus half times the spring constant k 71.8 times x squared, x equal 29 squared equal 3.43 times 10 to the power 4 joule. I hope that you will not find any problem, any question, any hard question in a practice page 166. They are homework, question 1, 2, 3, all of them easier than the sample problem page 165. Use the formula as well. The potential energy gravitational equal mgh, and the elastic potential energy equal half kx squared. Thank you. Solve the questions, the practice, that page 166, and send me your work in eSchool.